In this section of notes, we're going to take what we learned previously about confidence intervals for slopes of regression lines and then apply that to significance tests for slopes of regression lines. So just like in previous units where we had different confidence intervals and we had different tests, remember that there is a definite relationship between a two-sided test and a confidence interval. First of all, remember that all of the conditions are the same. So these are the conditions, just to remind you of the conditions that we used for our confidence interval. We're using all of the same conditions again. So remember, we're going to be looking at a scatter plot. We want to see that it looks like it is close to zero. We want to see that it's approximately linear, and then we want to look at the overall residual plot, and we want to see that they're evenly scattered around zero. So we want to see no pattern in the residuals. We want to know that we took a sample without replacement, and then if that was the case, that the sample size was less than 10% of the population size. We want to know that our distribution of our residuals is approximately normal. So we're either going to make a stem plot or a histogram or a dot plot or a normal probability plot, and we're looking for no outliers or strong skew so that we can say that those residuals are normally distributed. We want to look for an equal standard deviation in the residual plot. So remember, that's the sideways Christmas tree or the fan pattern that we do not want to see. And then we also want to see that random sample. And remember, all of these, if you look at just at the first letter, they kind of almost spell the word linear. And that's like a way for us to remember what all of these conditions are. Now, the mechanics of this test are pretty similar to the mechanics of previous tests that we've done. We've got the same general formula for our test statistic. So in words, we're finding our statistic minus our parameter divided by the standard deviation of the statistic. Remember that the statistic and the parameter are coming from our sample slope, and then the parameter is the slope in our null hypothesis. Usually that's going to be 0. And then we've got our standard error for our slope as our denominator. And then for our p-value, we're using a t-distribution, just like we did in the confidence interval, and we've got the same degrees of freedom of n-2. Remember, that's in most cases. There is a very small group of cases where if our line of best fit happens to go through the origin, then we use n-1 for degrees of freedom instead. But again, most of the time we're using n-2 for our degrees of freedom. Now recall that our null hypothesis is usually going to be something like there is no relationship between these two variables, which means the slope is 0. So our null hypothesis is going to be that the slope is 0. And then our alternative can be either that it's greater than 0, or it's less than 0, or it's not equal to 0. Remember that if you are going to be using your calculator, then you would use your TCDF, and that would allow you to put in your lower bound and your upper bound and your degrees of freedom. However, if you're going to use the table, remember that your table is only going to give you one value, and you have to know what you know about symmetry, and you can double, for example, the value you get from your table if you have a not equal to alternative hypothesis. There's also a LinReg t-test in your calculator. There's going to be a separate video for watching that. So rather than just using TCDF to get the p-value, using that test will also give you your test statistic and a lot of the other information that goes into your test just from that all-in-one spot. So make sure you do watch the video on how to do the LinReg t-test before you go through and try the practice problems.